Nanoscale science, from the viewpoint of physics, is about the fundamental nature of the materials. That is, what forces and energies are going to be involved at a nanoscale, because that's the fundamental basis of most of physics. Nanophysics is really looking at what you can do with those forces, how you can manipulate things at the nanoscale using forces that are a little unusual compared to the natural, what we generally see on a day-to-day basis. The area of nanophotonics uses light to manipulate materials, or the essence of the materials, the charges within the material, and that in turn will manipulate the light itself. So the nanophysics section of that is really what happens, what's the light causing in the material, and then what is the material going to produce, how it's going to change the light. But there are multiple other areas. Microelectronics is an obvious one. It's continually, transistors are shrinking in size, and processors are increasing in power, and you need to get down to the nanoscale level to continue the Moore's law, as it's called, the continual increasing power, doubling of power every 10 years, I think it is. And to get to small levels, you start to reach nanomaterials. And so what's the electronics going to do at that sort of scale? How do you make a transistor that's really that small? And that's another area nanophysics is going to be very important in. But it happens in multiple areas, nanoparticles, how they interact with their environment, all that sort of thing. So nanophysics, nanobiology, and nanochemistry all look at slightly different aspects of the nanoscale environment. Nanophysics looks at more the fundamental principles and what's going to happen, predicting what's going to happen at certain levels, whereas and it can go towards fabrication and things like that as well. For nanophysics, there are many, many different types of careers. As I mentioned, microelectronics is very interesting. Material science, producing materials actually atom by atom as opposed to in bulk, is a big area for nanophysics. Also, there's obviously the fundamental research section of it. There's photonics, such as telecommunications, all going to be impacted by the nanoscale world, and therefore are also going to be impacted by nanophysics, and nanophysicists would be ideal for each of those positions.
Northwest Missouri State University's Nanoscale Science degree opens up a wide array of career paths for students. Nanoscale Science is an interdisciplinary program that trains students in biology, chemistry, and physics. With this skill set, students can secure jobs in industry, government laboratories, or continue on with further graduate studies in science. Our students typically go one of three routes upon graduation. Many of our students will desire to get a job in industry right after graduation. So a nanobiology student, for example, will have these broad foundational courses that they've taken, as well as courses with the special emphases in biology. So with this background, they would be able to compete not only for nanobiology jobs, but also for more traditional biology jobs as well. And the same is true for nanochemistry and nanophysics. The second route our students often go is with government labs. So this could be things like the EPA or the DNR, the Environmental Protection Agency, or the Department of Natural Resources. So many of our students will go on to government labs afterwards. And the third route would be graduate school. So many of our students will go on for master's degrees or PhDs in science, and to a lesser degree, professional school like law school, pre-medicine, or pharmacy school. Many of our graduates will desire to secure a job in industry directly after graduation from college. Nanotechnology shows up in areas as diverse as consumer electronics and pharmaceuticals. The International Association of Nanotechnology, in its list of top 100 nanotech companies, includes companies with household names such as Hewlett-Packard, 3M, and Kodak. In the electronics industry, companies such as IBM, Toshiba, Intel, Texas Instruments, and Xerox are all investing in nanotechnology. Several pharmaceutical companies such as Liquidia, Bristol-Myers Squibb, Eli Lilly, and Baxter Healthcare are all researching the use of nanopharmaceuticals in drug therapy. Even the automotive industry, companies such as Daimler Chrysler, Toyota, and General Motors are all using nanotechnology in their products. All of these companies, from Procter & Gamble to DuPont to L'Oreal to Sony, are looking to hire graduates with training in nanoscale science. With the skills and laboratory experience acquired at Northwest Missouri State University, our graduates are equipped to compete for jobs in nanotechnology at the nation's leading companies, government laboratories, private institutions, or premier graduate schools.